You collected great data, but picking the wrong statistical test invalidates your entire study. Finding the right tool just means mapping three things: the number of groups, their relationship, and your data's shape. First up, when comparing the average scores of two entirely separate groups, the standard tool is the independent samples t-test. It reveals if the difference between them, like students taught with two different methods, is actually genuine. Next, if your study scales up to 3 or more independent groups, you need a one-way ANOVA. But it only flags if a difference exists. To pinpoint the exact winner, you need a follow-up post-hoc test. On the other hand, what if one group has an unfair advantage? That background influence is a covariate, which skews your results. To fix this, an ANCOVA mathematically subtracts that influence, leveling the playing field before you compare the final scores. Finally, the emergency exit for messy data. When you have extreme outliers or subjective rankings, standard rules break down. Instead of raw numbers, you compare their relative ranks using a non-parametric test, like the Mann-Whitney U. Every statistical test simply reflects your study's architecture. Match your group count and data type, and the math reveals the real story.